Hi guys, this is Miss Etheridge. Today I'm going to be working with you about the properties of integer exponents. Ms. Hardison and I have put together this lesson for you. You have a Google Slide document that is in Classroom along with this recording, and you will need to open that document, have the video going, and every once in a while you'll need to pause the video, you'll need to go to the document so that you can type in. The page looks just like it's a picture of the workbook, but we've added text boxes so you can type in as you go. Okay, so it's up to you. You work how it works best for you. If you want to go through, watch me on this first page and put in answers and we talk about it and you listen and then pause, and then you can go back, watch it again, pause, fill in your book. It's up to you how you do that. But I do ask that if there's a problem where I ask you to work it, to pause the video and to work that, then please do that. Try some of them on your own before you see what the answers are. Okay? This is as close as we can get for you to our in-class instruction. This is what we're doing in class right now. Our in-person students are in the same place you are. Okay? All right, with that, let's get started. Just a moment. Let me get everything set up. All right, so I am on page 2 in your book, but it'll be your first slide. So it tells you at the top, it says, in the past, you have written and evaluated expressions with exponents such as 5 to the third or 5 cubed and x squared plus 1. Now, let's take a look at this problem. So they give you 3 to the third times 3 to the fourth. And then they want you to answer some questions that go along with that problem. So let's look at those. A says, what do the expressions 3 to the third and 3 to the fourth have in common? So if you look at these two problems, 3 to the third and 3 to the fourth, they both have the 3 in common, right? And if you remember, those are called your bases. Okay, so they have the same base. Okay, they have the same base. All right, B says to write a multiplication expression without exponents that is equivalent to 3 to the third. And if you remember in your notes last week, when we evaluated expressions, we said the exponent tells you how many times that factor is being multiplied. So 3 to the third really just means 3 times 3 times 3. Okay. C says, well, then how many factors of 3 did you write? Well, we wrote 3 because that's what our exponent was. All right. D says, write a multiplication expression without exponents that is equivalent to 3 to the fourth. All right, so 4 is your exponent, so that tells you what? That tells you how many times you're multiplying your base. So it says, how many factors of 3 did you write? We wrote 4. All right, then F says, write a multiplication expression without exponents that is equivalent to 3 to the third times 3 to the fourth. So we're putting it together. We're getting the big picture. So 3 to the third, we said looks like this, times, remember parentheses mean that we're multiplying those, so times 3 to the fourth. So then I need 4 more 3's. So now it says, how many factors of 3 did you write? Well, we wrote a total of 1, 2, 3, 4, 5, 6, 7 3's. H says to write an expression with exponents to complete this equation, 3 to the third times 3 to the fourth. So if I'm just writing my answer with exponents, I'm not finding the true value of the number, I'm just rewriting with exponents, I'm really taking this number and writing it with exponents. So 3 is always your base, and 7 would be my exponent. All right, then I says, what is the relationship between the exponents of the factors and the exponent in your equation? So let's look at it. 3 to the 3rd times 3 to the 4th is 3 to the 7th. So what kind of relationship do we have there? We did what to the exponents? We added the exponents. Okay, because 3 plus 4 equals 7. So that gave us our new exponent. And then it says use words to explain how to multiply 3 to the 3rd times 3 to the 4th. So we kept our base, which was the 3, and we added the exponents, which was our 3 plus 4 that gave us 7. Okay? So that's where all those pieces came from. Now, I did that a little quickly, but remember, you can pause the video, you can go over to your document, and you can fill that in as we go. And now, when you're having to write exponents, instead of trying to find how to write, to type in superscript, and you can, or if it had been typing it into the calculator, we would have done 3, and we do the little caret symbol, the little rooftop, and then put your number. So anytime you have to type in something for us and it has exponents, you can just put the base, put the caret symbol or the rooftop, and then put what the exponent would be. We'll know what that means. Okay, it'll be a little easier for you to type that. All right, now moving on to the next page. It says that you have seen one example of how to multiply powers with the same base. So here are a few more. So we have 5 to the 8th, and they've color-coded it for you. So there's 8 of these 5s. So right there is 5 to the 8th. And then we have 5 to the 5th. That's in our blue. And then they showed you, they said, okay, 8 plus 5, and they got the new exponent of 13, and there are 13 5s. Then they show you one with variables. It works the same way. X to the 6th, so that's this first little group of red. And then we have X to the 2nd, so there's only 2 of them. 6 plus 2 gave us 8. Okay. And then they're summarizing it for you. So it says, in general, for the product of powers with the same base, any number to the a power times any number to the b power is going to equal n and a plus b, where n does not equal 0. Remember, 0 always throws it a little different. Okay? So let's highlight that. And you have a highlighter in your documents that you can do that too, or you can underline. So it says for the product, and product means what? Product means multiply, okay, with the same base. All right. It says you can also use the meaning of exponents to divide powers with the same base. So let's see what happens when we are dividing. Okay. So it shows you 4 to the 12th. They have stretched it out. There are 12 4s written there, divided by 4 to the 5th. Okay. Now, what they're showing you here is there's matches. So if I was going to do it in my own book, this is what I would point out to my students, that these 4s are canceling out. That's what they're showing you by stacking them right here. Okay, so all you have left, because those turn into, they reduce down, not really cancel, but they reduce down to 1s. So what you have left is 1, 2, 3, 4, 5, 6, 7 of the 4s left. Okay, so that's what they're showing you here. So think about that. How do we get from 4 to the 12th to 4 to the 5th? We ended up with a 7. What's that relationship? Well, if we look down here, it tells us that if we subtracted the exponents, then we would get that rule. Okay? So I'm going to do a little highlighting. I know you can highlight. You can add text boxes to any of those pages if you want to like type in some extra things. We're putting text boxes for you on the main blanks, but anytime you want to insert more notes, you can do that, and that would be great. You can highlight, you can use different colored ink. Just play with it. It's okay. It's your copy, so you're not messing up our copy. You can go back and fix whatever you want. Okay, make it yours. Make it make sense to you. So saying that, I'm going to put a little note up here, and if you can add that to your notes, that would be great. So we subtracted. So I like to tell my kids that when they're stacked, so 4 to the 12 over 4 to the 5th. So when they're stacked, you subtract. That's how I get them to remember that. Okay? And we're talking about the exponents. We keep the base. So right here it says, so in general, for the quotient means divide, of 2 powers with the same base, then you're going to subtract. Okay, just like up here when we were multiplying and there was product of powers with the same base, we added. Okay, so we added here. So we add exponents when we're multiplying, and when we're dividing, we subtract. Okay. All right, so now I want you to pause the video and I want you to think through on number 1 what your answer would be, and I want you to show how you got that answer. Give it a little thought. Now after you've answered it, then you can unpause and carry on. Okay, so you have answered the video now. If not, pause it, but you're taking the time when you hit pause. So it says explain 5 to the 10th over 5 squared equals 5 to the 8th. So 2 different ways you could have showed that. You could have said that, well, 5 to the 10th minus the 2, you're showing the subtraction of exponents. That gives you 5 to the 8th. Okay, that would have been fine. I could have also shown, I could have put 5 times 5. I could have done it 10 times. So make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it said 5 to the 10th, and 5 squared. Okay, I like to mark out what matches. So this is what I have left. I have 1, 2, 3, 4, 5, 6, 7, 8. So that's how 5 to the 8th is your answer. Okay. All right, moving on to the next slide. All right, now this page is talking about product of powers. It says read the problem below and then explore how to find the product of powers with the same base and the same exponent. So let's look at our example. It says 3 squared raised to the 4th power. That's how that's read. All right, it says means 3 squared multiplied as a factor 4 times. So it means you have 4 of these 3 squared. Okay, so that's what that means. All right, it says 3 squared to the 4th is the product of 4 powers, each with the same base 3 and the same exponent of 2. Okay, so let's think about what we already know. We've already stretched it out to see how many we've gotten. Okay, so keep that in mind. All right, now look down here. They tell you that you can use the associative property to find your answer. It says 3 squared raised to the 4th is the product of 4 3 squares multiplied together. So they're showing you, hey, you could group it up and make it a little simpler, okay, like we've seen on the page before. So these 2 3 squared was really just 3 to the 4th. These two are 3 to the 4th, and we just saw on the other page that when you have the same base, you just add the exponent. So 4 plus 4 is 8. Okay? So that's what I'm hoping that you noticed up here. This is still all the same thing. We're same base. We're just adding the exponent. So 2 plus 2 plus 2 plus 2 is 8. Okay? All right, now let's look on to this next page. I'd like for you to pause the video and see if you can answer the numbers 2 through 5 on your slide. You do have enough information already to be able to answer those. So pause it, answer, and then come back to check your answers. All right, so number 2 says 3 squared raised to the 4th. Well, we just saw it on the other page, and that is 3 to the 8th, because we said we were grouping those. But let's think about it. It says describe the relationship between the exponents of 3 squared raised to the 4th and the exponent 3 to the 8th. Instead of writing it out every time, 3 squared times 3 squared times 3 squared times 3 squared, couldn't I just multiply these numbers? 2 times 4, that gives me 8, correct? So we can multiply the exponents. All right, number 4 says to complete these examples of products and powers that have the same base and the same exponent. All right, so they're giving us 5 to the 8th raised to the 6th power. So they're stretching out that 5 to the 8th. They've got it written 6 times. So they said, okay, that means there are 6 of those 8s, and 8 times 6 is 48. Now notice we're still not finding values. We're just simplifying. We're just rewriting using an exponent. All right, and the next one, it says 953 to the 7th raised to the 3rd. So that means there are 3 of those. So we have a 7 every time. So 7 times 3 is 21. Okay. So number 5 says, all right, let's put it into words. So in general, the product of powers, so I'm going to highlight that. If you have your highlighter, you can do that. It says the product of powers have the same base and same exponent in A raised to the B would equal in A times B. Okay, so let's make a little note. And remember, you can add a text box. You can make extra notes even when there's not a text box already there for you. So when we're doing product of powers, same base, same exponent, we multiply the exponents. All right, now let's look at this middle section. Now it says, now let's look at how to simplify a product of the power when the bases are different. I'm going to take my highlighter and I'm going to highlight that. Bases are different and the exponents are the same. So this is just the opposite of what we had. So now we have 2 to the 3rd times 4 to the 3rd. All right, so let's look at this together because you haven't seen these. It says write an expression without exponents that is equivalent to 2 to the 3rd times 4 to the 3rd. All right, so think about 2 to the 3rd really means that. 4 to the 3rd really means that. Okay. All right, so 7 says, well, apply the associative and commutative properties of multiplication to write your expression as a product of groups of 2 times 4. So think about, here's a pair, here's a pair, and here's a pair. So I really have 2 times 4 times 2 times 4 times 2 times 4. So it says, how many groups of 2 times 4 do you multiply together to get this same combination, 2 to the third times 4 to the third. How many groups did you have? You had 3 groups. So let's put that together. It says complete this equation. 2 to the third times 4 to the third equals 2 times 4 to the third. And 2 times 4 is 8. So let's put that together. It says, in general, for the product of powers, so product of powers that have a different base and the same exponent, so a to the n times b to the n, we really just do a times b to the n power. So we multiply the bases and keep the exponent. Okay, well, just exponent on the S on there. Okay. So far that's 3 rules that you've learned. Okay, we did where we're multiplying with the same base, we add the exponent. When we actually, you've got 4 rules, and when we're dividing, we said you keep the base and you subtract the exponent. At the top of the page, we learned when you're raising a power to a power, you keep the base and you multiply the exponents. And then our last one today is when you are multiplying, you have different bases and the same exponent, you multiply the bases and you keep the exponent. So 4 ways to work this problem out. It just depends on what you're given. All right, so now let's work these last few. It says use what you've learned to solve these problems. Write your answers using exponents. So we're not finding the big numbers, we're just simplifying. It says to show your work on a separate sheet of paper, but we're doing it all right here. I want you to pause it and see if you can get number 11 and 12. All right, so looking at number 11, it says 2 to the 18th raised to the 8th. So we said if you're raising a power to a power, you multiply the exponents. So I just got to know 18 times 8, well 8 times 8 is 64, and I carry the 6. 1 times 8 is 8, plus 6 is 14. So I have 2 to the power of 144. All right, number 12, it said 4 to the 9th times 25 to the 9th. And it gave you an OR here. So let's do this first. Let's say 4 times 25 is 100 to the 9th. Okay. And here we could have shown it like this before we did the multiplying, but this one is sufficient. Okay. All right, now that's all that we're going to cover in your textbook today. You do have some pages in the practice and problem solving workbook. We'll have those on Google Classroom. So once you get finished with these notes and you are finished with the homework, you need to upload photos, you'll need to upload photos of the homework, and then you'll need to be sure when you finished with this that you submit so we can see that you are taking notes as we go. Once you submit this document, we'll be able to look at it from now on. So tomorrow when you take notes, you won't have to resubmit again. You can just keep going. Okay, we'll adjust that if we need to. It may be that once we look at it, we have to return it to you. We're still getting the hang of this too, so we'll get there. But we will be looking at both the class notes and the homework pages. The homework pages you will have to take a picture of and upload your work. You don't have to print the homework pages out. We're going to send you a picture of those. Either we'll send you a picture or we'll upload it into Docs. We'll see which way works best for you. but that you can do on your own paper. Okay, guys, talk to you later. Work hard.